Your warm-up says classify the conic given by 4x squared minus 25y squared equals 100. Any ideas? Yeah, let's divide everything by 100 and see if that gives us something that looks familiar. So this is going to be x squared over 25, because 1 over 100 is 1 over 25, minus y squared over 4, because 25 over 100 is 1 over 4, equals 1. Can you tell what kind of conic this is now? Ellipse would have a plus sign in the middle. This is a hyperbola. Any questions? The only difference between the equation for an ellipse and a hyperbola is the minus sign. Ellipses have a plus, hyperbolas have a minus. Any questions? Alright, today we are starting 10.6. It's all about graphing and classifying conics. If you read over the goal, you will see that we are now going to look at conics that have a vertex that is not at 0, 0. It's actually going to be at a different point. We'll call that point HK. So if you remember everything we did with graph transformations first semester, this should not be too challenging. It's basically all about the graph transformations. If you have forgotten that, I will give you some new standard form equations to look at. Since most of the chapter had graph centered at 0, 0, most of your tests will be graph centered at 0, 0, but there will be a few like this on there as well. Any questions? All right, here they are. So in the following equations, the point HK is the vertex of the parabola and the center of the other conics. So as you're writing these, you might notice that they're the exact same equations as we had before. Every time you see an x, you're just subtracting an h. Every time you see a y, you're just subtracting a k. Subtracting an h from the x value is just going to shift our whole graph to the right. Subtracting a k is going to shift it up. So some of you will be writing all these down. Some of you will just take what you know about graph transformations and apply it that way. But these are equations you should be comfortable with. Like I said, they're the basic conic equations that you should already know, or at least have written on your note card. Everywhere you see an x, though, you're subtracting an h. So let's say x minus 2, you would just move everything to the right 2. If this was x or y plus 7, that means you're subtracting a negative 7, you're going down 7. Like I said, these do get a little difficult. You'll see as we get going, it kind of takes a deeper level of thinking, but you can definitely handle it. All right, here's our first example. So it says, write an equation of the translated parabola. So we have the vertex at the point 3, 2. We have the focus at the point 3, 4. Remember, the focus is inside of our parabola. So looking at the focus in relation to the vertex, which direction is it? Well, let's draw it if you are having a hard time visualizing it. So this is your coordinate plane. You're going over 3, up 2. Here's your vertex. To get to your focus, you're going over 3, up 4. So how is the focus related to the vertex? It's above it, right? Yeah. So this parabola is opening in which direction? Up. Okay. This distance right here, we always call P. What is P? 2. Okay. Those are the things we need to know. Any questions? That picture's going to go away in a second. All right. The two things we just decided, it's opening up. And I know that my P is 2. So I am going to look at the equation for a parabola opening up. That is where the x is the squared part. You subtract from your x the x value of the center. So what number is going to, or sorry, the vertex in this case. So what number is going to go right here? 3. P goes here. And then you subtract the y value of your vertex from here. What's the y value of the vertex? 2. There you go. The 3 goes here. The 2 goes here. The P goes here. Now, some people feel tempted to distribute that 8. When you distribute the 8, we no longer can very quickly tell where the vertex is, so I would not distribute the 8. I would leave it factored out. The 8 represents our 4P, so if you divide it by 4, you could easily see that P is 2, and you know right where your vertex is. All right, just like last time, I think it'll be beneficial to visualize this. Some people can do it in their head, some people cannot, so I'm going to go ahead and just graph these two things for us. So we're going up, we're going right 1 up 2 to our vertex, then we're going right 5 up 2 to our vertex, or to our focus. So which way is this opening? To the right. P is this distance right here. What's P? 4. So right away I know that I'm going to be using the equation that has the y squared because this is opening to the right. I also know that I'm going to put 4 in for the P value because these are 4 units apart. Now, if you can't just see that by looking at the graph or sketching it, what formula would tell you how far apart these are? The distance formula. So if this is not something you can easily visualize, use the distance formula. All right, that little sketch is going to go away, so soak it all in. But here are the two things we decided. We decided it's going to go right, which means I need to use the equation with the y squared. We also decided that P was 4. What number are you subtracting from your y? 2. It's the y value of your vertex. Same thing for the x. You are subtracting the x value of your vertex. And then I'm going to just pop that 4 in for the P. The only thing I want you to multiply out on these is the 4 and the P, which in this case is also 4. Like I said, if you distribute this, we can no longer easily tell where the vertex is and what P is, so I would not worry about distributing it. And I definitely wouldn't double distribute on the other side. Questions? All right, this next one is pretty difficult. First thing I'm going to do is just a quick sketch of what I have. So there are my vertices. My foci are inside. And I don't really know the covertices right now, so I'm just going to sketch it, but just keep in mind this is definitely not the graph, okay? We don't know how wide it should be, but this is what we know so far. So there are a few things I need before I can write the equation, right? I need the center. I need to know the direction that our axis is going, our major axis. I need to know A, right? And I need to know B. Once I have all those things, I'm pretty sure I can write the equation. Do we know the center right now? No, but we do know that the center is going to be located at the midpoint between our vertices. So let's use the midpoint formula. That would be 3 plus 3 divided by 2 and 6 plus negative 2 divided by 2. So I have a center at 3, 2. Now, do you actually need the midpoint formula if you're a really good sketcher? No, just count from each direction until you get to the center. So you could put one finger up here, one finger down here, and just count until your fingers are meeting. All right, it'd be the point right here. All right, which direction is this going? The major axis always has the vertices and the foci on it. So this is vertical, which means the A needs to be under my y squared. Do I know A? A is always the distance from the center to the vertices. So if this is 3, 2 and this is 3, 6, what's A? 4, okay. Do I know B right now? I don't, but I do know a little bonus. I know C, right? Because C is the distance from the center to the focus. So if this is 3, 2 and this is 3, 5, what is the C value? 3. Okay. I also know that in this case, C squared equals A squared minus B squared. So this would be 9 equals 16 minus B squared. So when I subtract 16 from both sides, I get negative 7 equals negative B squared. So what's B? Oh, you can make them both positive and then take the square root, right? So B is? Square root 7. Good. All right, I'm just going to write the general equation for an ellipse not centered at 0, 0. Now, since this is vertical, where does the A squared go? Under the X or the Y? Vertical. Under the Y. So I need to put 4 squared right here. What is 4 squared? 16. 16 goes there. I need to put b squared right here. What's the square root of 7 squared? 7. The x value of your center is what you subtract from the x. Of the center, 3. The y value of your center is what you subtract from your y, 2. Amazing. These are hard. What are your questions? All right, graphing these is actually a lot easier, I think, than writing the equations. So let's look at some graphs. All right, so we are supposed to graph this conic. What conic do you think this is? It's a circle. It is. You're right. It's a circle. Nice. We know it's a circle because there are no coefficients here. If this was like a 9 and this was like a 3, then we try dividing everything by 9, see if it fits into the ellipse or hyperbola category. It's obviously not a parabola because both variables are squared. This is a perfect square. That's kind of a good tip-off. It's a circle too. Those are pretty easy. But yes, this is going to be a circle not centered at 0, 0. Does anyone know where the center will be? What are they subtracting from the x value? -3. What are they subtracting from the y value? 1. So that's where my center is. What's the radius? 3. So from that center, go 3 in each direction. And you're done. Now, circles in general are the easiest, so I don't want you to think they're all going to be this easy. But the hardest part is just finding that center. Once you're good with that, you should be good to go. Any questions? What is this? An ellipse. Very good. Now, notice the x squared is after the y squared. Does that matter? No, it's a plus sign, okay? If you feel more comfortable with the x in the front, do it. Now, what are they subtracting from the x value? What are they subtracting from the y value? So my center is at the point 4, 2. Now, which one of these is A? Yeah, the 4. The 4 is the A. It's below the Y. So this is going to be vertical major axis. So if I'm doing side to side first, I would look below the x value. The square root of 1 is 1. So that's your B value. B is 1. So you go to the right one, you go to the left one. Those are your covertices. We already said it's vertical, so look to the larger one, take the square root, and that's going to tell you how much you're going to go up and down. That's your A. Two. 2 up, 2 down. Draw on your ellipse. Now, as far as like writing your covertices as ordered pairs and your vertices as ordered pairs and labeling your foci and all that kind of the more nitpicky stuff of conics, I'm not requiring you to do all of that when the center's not 0, 0. If you can just tell me how many you're going in each direction, I'm completely fine with that. So these are less detailed. They're more sketches, I would say. But they do get a little more complex because you're no longer at 0, 0. The math isn't all nice and neat like it was. Any questions on number 5? Here's number 6. This is, in my mind, the easiest conic to pick out. This is parabola. You know it's a parabola because only one of the variables is squared. Which way is this parabola opening? Your x is the squared one, right? So this is opening up. Very good. Up or down, and then you can look to the P. P is positive, so it's going to be opening up. Where's your vertex? This is where you ask yourself, what are they subtracting from the x? What are they subtracting from the x? -2. What are they subtracting from the y? -3. So your vertex is at -2, -3. Next thing you want to decide, what is P? Remember, P is always being multiplied by 4. P is 1 in this case. So your focus is going to be 1 unit up from your vertex. Your directrix is going to be 1 unit down from your vertex. That's all you need. Questions? What conic is this? Hyperbola. Why is it a hyperbola? The minus sign. If it was a plus sign, it'd be an ellipse. It's a minus, so it's a hyperbola. The big tip-off is that it equals 1. And you have denominators under your x squared and your y squared. For our center, again, what are they subtracting from the x?
2.
What are they subtracting from the y? -5. That is my center. Now, remember, for hyperbola, it matters which variable is in the front. So we have the x squared in the front. So this is going to be Horizontal or vertical? Horizontal. Very good. In the horizontal direction, how many units are you going out from your center? 3. In the vertical direction, how many units are you going out from your center? 4. Once you have those, this is where we draw that box. I'll pause here, let everyone catch up. Hyperbolas, I keep saying this, are in my mind the most complex. So go ahead and take some time to get all your details. All right, once you draw the rectangle in, the whole point is to get your asymptotes. And now we can draw our hyperbola in. Like I said, I'm not going to be super nitpicky about finding things like the foci and the equations for those asymptotes when the center's not at 0, 0. Will be a little less detailed than the ones that are centered at 0, 0. So make sure that you're going through your 2 vertices. You are approaching your asymptotes without touching them. What are your questions on this? All right, so we're going to stop there for the day. This is your homework assignment. You should not be able to do 51, 53, 55 just yet. I think you can at least get started on the rest of them. We will finish this lesson right where we left off on Thursday. Remember, Tuesday and Wednesday we're doing the park test. I would definitely bring your homework along and work on it if you happen to finish early. Homework check is a week from today, so stay on top of this stuff and let me know if you have questions.